Good morning. Today we are going to be working through the water cycle. So we were talking yesterday about this concept of atoms or particles or compounds, how they're going to exist as a solid, as a liquid, and as a gas. And then we mentioned temperature, and temperature was a very important factor in whether or not it was a solid, liquid, or a gas. So just to recap, we spoke about how solids, liquids, and gases are always in motion, right? There's constant motion in those particles. And so we talked about how solids are going to vibrate in place, liquids will flow past each other, and gases will move independently. So what does temperature have anything to do with the states of matter? Well, temperature, we spoke about it briefly. Temperature is basically the measurement of the speed of particles. Let's say atoms, particles, whatever. Okay? So it's the measurement of the speed of particles, all right? And so we know that there's basically a scale, right? We have cold, right? Or hot, all right? And there's a scale. So how cold something will be and how hot something will be. And we know that there's these very extreme, examples of cold, very extreme examples of hot. By the way, there is an absolute zero. Scientifically, we have never been able to achieve absolute zero as far as temperature being cold. And what absolute zero means is that particles aren't moving at all. We've gotten very close to that point, but we've never gotten to the point of absolute zero. But that does, now, don't mistake that for 0 degrees or, because we're going to talk a little bit about what 0 degrees Celsius means. Absolute zero is like negative 270, I believe it's negative 273 degrees Celsius. It's like really, 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 really cold temperature. Scientists actually measure in different units called Kelvin. But we're not going to get too into that. But there is a point, and this is what you should know, there is a point of absolute zero. And absolute zero means particles aren't moving at all. And we haven't even gotten to that point in all of, our measurements in laboratories and in all of our experiments. We haven't even been able to achieve that. But the point is that what does that mean? It means when particles are not moving. Because temperature, the scale of temperature, measures the rate of movement, right? How fast particles are moving. So we have cold and hot. That's how we measure it. Well, what this really means is that the colder something is, the slower it's moving. The hotter something is, the faster it's moving. So that's what the scale means. And then there are different points to that scale, moving faster or slower, depending, right? And so temperature is going to affect, very much going to affect, the state of matter of different particles, right? Because if the state of matter, it is determined by how fast or how slow the particles are moving, for instance, solids just vibrating, liquids flowing past each other, gases independently moving from each other, right? So if the temperature is a measurement of how fast or slow something is moving, the temperature is also going to determine, right, what state of matter something's in, okay? So that should make sense to you, all right? Temperature is the determining factor of whether something will be a solid, a liquid, or gas. And we know this from our everyday life experiences, right? So let's kind of go into that example, okay? So we talked about how water, okay, because we're discussing this idea of the water cycle. Okay, so we have water. We know, not water. So we have solid, H2O, right? And we call that ice. Liquid H2O. I think it's just called regular. I mean, it shouldn't be called water, but whatever. Liquid water. And then there's gas H2O, which is vapor. Vapor, steam, right? And so there are different states of how this H2O, this compound, could exist in. And by the way, all things have the ability to be a solid, a liquid, or a gas, or a plasma, right? All things, all elements, not just water, right? All things. And if you think about it, if I took water and I put it in the freezer, okay, which is roughly somewhere around 0 degrees Celsius, okay, it will turn into ice, okay? Because at that point, water will turn into a solid. H2O will turn into a solid. But what happens if I have a bottle of vodka? If I put that in the freezer, it looks the same as water, right? It's still a transparent liquid. It looks the same as water, but if I put that in the freezer, it won't turn into a solid because the temperature is not low enough to take alcohol from a liquid form into the solid form. Those particles in the alcohol are still moving relatively fast, and that temperature does not slow it down enough for it to turn into a solid. And so I can have water in there and it be ice, but I can have alcohol in there and it will still be liquid. Okay? If I were to lower the temperature more, right, because alcohol has its freezing temperature, it would turn into a solid as well, right? So everything is going to have its own freezing point, everything is going to have its own boiling point, everything's going to have its own point of where it's going to be in different states of matter. So we're going to talk about different states of matter, and it's, when it transfers to a different state, right, based on the temperature, it will determine what state it's going to be. By the way, regular normal room temperature, gold is a solid. If I heat it up enough, if I add enough heat to that system, to that gold, what happens to it? It turns into a liquid. But the temperature is so high. It's like, I think it's like, I would be talking off the top of my head, but maybe like 300 degrees Celsius. I don't know. I'd have to look it up. But something like that. Whereas water, right, normally would turn into a liquid at regular room temperature. Whereas gold is a solid at regular room temperature. So every single material is going to have a different temperature at which it's going to change into the next state of matter, okay? Whether a solid, a liquid, or a gas. So change of states, and this has to do with how fast or how slow the particles are going. So we have a solid, we have liquid, and we have gas. Okay? 3 different states. And by the way, there's also plasma that we'll kind of touch on at another time. But we know that when solid turns into a liquid, it's called melting. And scientifically, we call it the melting point, right? At which point will a solid turn into a liquid? That's going to be its melting point. But on the opposite direction, when a liquid turns into a solid, it's freezing. Now, by the way, that temperature, the melting temperature and the freezing temperature are the same, right? At that point, at that temperature is when it could transition either to become a solid or to become a liquid, depending on the temperature. It's that temperature, but how fast those particles are going to continue to move. Is it going to move faster and become a liquid, or is it going to move slower and become a solid? Now, from a liquid to a gas, and some of you might be familiar with this, right? When a liquid turns into a gas, it's called evaporation. And when a gas turns into a liquid, it's called condensation. So I don't know if you can actually read it off the board, but evaporation, evaporation. So that's evaporation. And condensation, condensation. So evaporation is when a liquid turns into a gas, and it happens all the time, right? If I were to keep a cup of water on my table, I'd come back a couple of days later, it would have evaporated. Condensation is when that gas, right, is going to turn to a liquid. It happens, when it rains up in the atmosphere and then the rain comes down. Sometimes you'll actually see it on the windows, right? If you have some gas in the room, right? There's some steam in the room, and it gets to the windows, and it's a little colder on the windows. You'll start to see a little fog on the window. That's condensation. Sometimes you'll see it even, in the grocery store, the freezer. You'll see some condensation on the windows. Then we have from solid to gas and gas to solid, and that does happen. There are certain things that do go from straight from a solid to a gas. That's called sublimation. Sublimation, sublimation. And from a gas to a solid is called deposition. deposition. All right, so these are the different states. We're going to talk more about these tomorrow, but these are for now what you should know. Have a wonderful day.